Hi, my name is Paul Meeks. I'm the president of Worthington Products, and I am very pleased to have with me Chad Shaw. Chad is the chief of the Fox River operations for the U.S. Army Corps of Engineers. And in the brief time we have together, we're going to talk about the 7Ps as they relate to waterway barriers. And for those of you who are in the military, or have been in the military, you probably heard this before, and you will know right off that the word pitifully is changed with a different four-letter word that I chose not to use. For those of you that are not in the military, the 7Ps stand for prior proper planning prevents pitifully poor performance. So let's take a look at this, how it relates to the design and execution of effective waterway barrier projects. Now, I want to start by looking at some headlines in 2020, and no, these are not COVID headlines, but these are actual examples. And here is a headline that none of us as engineers or especially as power producers ever want to see, and that is causing a national blackout. But that exactly is what happened in April of 2020, when just 15 minutes before the president of Uganda was set to address the nation in a national televised conference regarding COVID, the lights went out. A national power blackout happened. And here you're seeing an aerial image of a lot of floating weeds that had broken loose due to high water. They came down and they blocked the power plant. You can barely see the power plant in the lower left-hand corner here. And you see a lot of excavators sitting on this roadway removing all this debris. Nationally, the power was out for, I believe, about 3 hours. This particular power plant was offline for more than 14 days. So you can imagine the cost for the cleanup on this, but also the cost to the reputation of the National Power Company when this happened. Here is another example, and again, it's the same utility. I'm not trying to pick on them intentionally. I just had these examples handy. This happened in August of this year, and sadly, it involved a tragedy of a mother and her son who were on a tour boat, a small tour boat, and the engine failed on the boat. It happens all too often, and the boat went through the spill gates. Now, I just want to say this happens all over in the United States as well. What made this exceptionally notable was that the mother and son were wife and child of a very prominent African citizen, and so this made not just national, but it made world headlines when it happened. So these are headlines that, had there been prior proper planning, some of these things could have, most likely would have been avoided. Now, the headlines you saw were of bad things that happened, but if you plan your projects properly, your headlines are going to be different. And here we see another example. I'm just using Africa this week for some of my examples. This is an example of a weed boom in Malawi, and in this case, again, another example where the national power supply shut down due to weeds blocking a series of critical hydroelectric power plants in that country. In this case, after years of planning and engineering, consideration, and construction and installation, a new weed boom was put in 2019, and it will solve the hyacinth problems and the power blackouts and the effect on national power production and industrial production in that country. So there's an example of planning that actually works. A little closer to home for all of you, and especially for Chad, are prior proper planning that took place on the Fox River. And here you see an aerial image of a newly installed boat barrier line that will be used to safeguard the public from going through these dangerous spill gates or over the dam. And we'll get into some of the challenges on that project here in a very short while. So what does it mean to plan for a project rather than just say, hey, I need to put some booms out there? Well, it means you need to approach this by considering multiple factors that go into getting an achievable solution. We're not going to get into details on all of these, but just you can see the list here. River hydraulics obviously have a lot to do with it. Your water velocity, any types of debris, wind waves. An important thing is going to be the function of the boom that you want to put in. Do you want it, if it's for debris, using that example, do you want it to stop the debris, to collect it? Do you want it to divert debris down to your competitor's power plant? We need to look at all of these factors. We need to look at water level changes, the location of spill gates, anchoring capabilities, and even things like the type of equipment you might have available and the window of opportunity you might have available for installing a boom line. So these are all things that need to go into the proper execution of a boom line before you even come out to bid. And it's very important to note that approaching a project with a one-size-fits-all mentality does not always work. In this case, we're showing an example of what normally is a very good barrier material. In this case, it's HDPE pipe. However, we're familiar with the site, and there is very little planning that went into this, and that's why we're seeing a boom line that's just not effective. So every project should begin first by defining the problem and the desired outcome. And this should occur before you define the solution or the product. And the solution-based approach we have found results in getting the right solution for your particular problem and getting the results that you actually were hoping that you would achieve. Now, I showed you in the previous slide a picture of one of our competitors' products, so I want to make sure that you're well aware that Worthington has our share of bad installations as well. And here's an example where, hey, a lot of you know us for our tough boom product. And in a lot of sites, tough boom just, let's face it, it is not the right solution. And here you see an example in another one in Malawi. This is the predecessor to the large boom line I showed you earlier. And this thing was just woefully inadequate to the site. And I will say this, zero planning went into this boom line. We shipped a boom, and client put it in and found out, well, it didn't work. Well, shame on us. We should have asked the right questions, and eventually we replaced it with a proper boom line. So what needs to take place as you approach a boom project? Well, I would suggest to you that it starts by pulling up aerial images, gathering your data about the site, and then reaching out to boom manufacturers, because they all have, if they're good, they all have a degree of experience and expertise, and they can give you wonderful advice about what your various options are for boom lines. And here we see an example of some projects. This is an initial discussion that we had with a client down south, and we're looking at options, and we're presenting them with what their options are, and often we'll talk about what the pros and cons are, and we'll talk about what the considerations are. And you see on each of these, you'll see a solid line and a dashed line, and I want to point out why that's important. Because often we see on a drawing a straight line indicating where the boom is, but the boom always has some amount of sag. And so we believe it's very important that when you're looking at your options for boom positioning and type of boom line and everything else, is that you actually have some idea of how this thing is going to look once it's under load or under flow or where you have wind blowing on it. And in this case, it allows you to have a upfront and frank discussion with the boom manufacturer, with the project owner, with the project engineer, so you understand what the components are that are going to be required on these things. And one of the important features on all of this, and I can't emphasize enough, is always going to be your anchorages. Because anchorages are complex, and they can also be very costly. Let's take a look in the lower left-hand corner. Here you see what is probably a very inexpensive anchor. It looks like they probably just took a sono tube, bored out a hole in the ground, and filled this with concrete and then connected an anchor plate. That happens to work for that particular boom line. But some of the other pictures that you're looking on here are not so simple, and they're not so inexpensive. In the upper left corner, we're dropping some anchors in a deep reservoir, and there's some serious equipment and costs that have to come in. The middle bottom photo, it may look benign, but if you look really close, you can see you're seeing these little concrete blocks, but those aren't the anchors. They're sitting on top of the anchor. And if you look close, you'll see one massive chunk of concrete that had to be poured here. If I remember correctly, that's probably 15 feet wide, 15 feet long, and I want to say it was 5 feet deep. So the client had one huge shocker when they did the engineering after they issued the project for bid, and they found out that they were going to have a concrete block that was going to be more costly than the boom line. And then in the upper right, you see another example. So anchors are so critical to a job, and they can be extremely costly. So you need to have a consideration of your anchor type, the location, the quantity, and the installation logistics before your project goes out to bid, even if it's for a design build project, because that's going to affect the overall cost. And I'm going to ask you something just to consider. How the heck can a contractor bid a job if they do not know the anchor details? And if you just put on a bid document, well, the boom manufacturer is going to tell you all about your anchors. Slow down, folks. If we don't have all the operational conditions, how can we tell you what the anchor size is going to be? If we don't have borehole data, we don't know if there's rock, if there's sand, if it's below the water line, above the water line. So this is information that needs to be addressed before a project goes out. And it is so absolutely critical. So this brings us around to the recent installations along the Fox River that Chad did. And there was a lot of prior planning in there, and I'm going to say a lot of prior proper planning. And so what we want to do is just start. Chad, maybe you can give us a brief overview of what you folks did and what some of the challenges are. And I understand that as you came into this project, you had a lot of planning, maybe a lot of excessive planning, if there can be anything such as that. But if you would just give us a brief overview of what you did there, and then hopefully we'll have some folks out here that will ask us some questions. Thank you so much.